Welcome to another episode of Block Talk. My name is Cody Bourne, and I'm joined today by Supriya Madhuram, who is a software engineer on the Azure blockchain team. Welcome to the show, Supriya.
Thanks, Cody. Happy to be here.
So today we're going to be talking about Ethereum Logic Apps. So a logic app is essentially an if this then that type of connector that you can build within Azure. So it allows you to take any type of input connector and connect it to a set of output connectors. You can string together as many of these different connectors as you want. Usually a flow will start with some kind of trigger. So it could be an event that's fired or some kind of message that's passed to your logic app connector. And that will trigger a cascade of different actions that you can take. So there's triggers and then there's actions. So the thing that we're going to be looking at today are a set of triggers and actions that are specific for blockchain. And the ones that we've built are for the Ethereum blockchain network.
Yeah. So the blockchain engineering team has created a new Logic App Connector for Ethereum blockchain networks. So basically what this allows you, this is our latest offering in the connector space in Azure. What this allows you to do is use your smart contracts that you have created in a blockchain network and incorporate that in any Logic App workflow using the familiar triggers, actions paradigm. So what we have is, we've exposed some actions and triggers on smart contracts that you can then use to create a good Logic App workflow.
That's really cool. So the reason I like this a lot is because in the Logic App marketplace, you have today over 200 different connectors. Some are enterprise focused, some are consumer focused. And so this really unleashes Ethereum and allows you to integrate with all of these different connectors into your existing system. So some examples are I could use Ethereum to send an email or take an email and have that being pumped into the blockchain network.
Right.
So let's take a look at how to actually set this up.
Okay, so I have a demo with a simple Solidity contract that I have already deployed to a blockchain network. Here's the contract I have in Remix. Okay, so this should be clearer. Better. Yes. Okay. So this contract is really simple. As you can see, all it does is allow you to post a message to the contract, and when a message is posted to it, it emits an event on the blockchain network and increments a counter. And it exposes a couple of public methods where you can get the message that you last sent it and also the count. Very simple contract.
Okay.
So using this is something I have already deployed to a private blockchain network, a POA network.
Well, could you also use a public Ethereum network if you wanted to?
You could.
Okay.
Yes, you could. And once this is deployed, now I can incorporate this contract in a new Logic App workflow.
Okay.
And I'm going to show you how to create a new Logic App using this connector and this contract. Okay. So I'm now going to the Azure portal, and I'm going to create a new Logic App resource. Search for Logic App. Here we go. I create a new one.
So right now, Supriya is creating a Logic App, which is essentially a container of a single flow. And so you can think of this as going to be a blank canvas that allows us to set up a set of connectors that will form our actual Logic App.
Okay, this should be good.
So this is being created. Let's talk about what is the goal of this logic app that what are we trying to achieve in this demo?
Okay, so I'm using this demo to showcase some of the functionality that this logic app connector exposes. So basically, I'll be the workflow will be listening for events that are emitted by this contract, and I will also show you how to read some state on the contract by calling some of the functions that it exposes, and then have it be incorporated in a workflow where it calls another connector. Say, I'm going to show you how to write to a blob storage. The output of a connector of this connector will make it to blob storage.
Okay, great. Okay. So I think it's finished deploying. So let's take a look.
Okay. Here's the deployment. And immediately you're put into the Logic Apps Designer page where you can go and create the blank Logic app. And it pre-populates it with some of the connectors that I have been using in the last two Logic apps that I built. So, for example, I have the Ethereum blockchain. If it weren't there, I would just look for blockchain, and it would show me the blockchain connector. And so the only trigger that's exposed on it is when a smart contract event occurs, and I select that as the beginning of my workflow. And so now when I create this workflow, I'm going to be talking to the blockchain network and the contract that I had created initially. So for that, I need the Ethereum RPC endpoint so that the Logic app can read the contract state and call the APIs that it exposes.
Got it. So I can think of this almost like a database connection.
Yes. Yes. Okay. And this is my Ethereum network, and okay. And the private key, like you can see, is optional because it doesn't have an asterisk on its name. You don't need the private key to just read state on the smart contract or listen for events. But if you wanted to call any function that incurred a gas cost where you have to sign the transaction, at that point you'd need a private key. But this demo doesn't require that, so I'm not going to put in my private key.
Okay.
But if you did, it's backed by Azure's security guarantees and to be safely stored.
Got it. So essentially anybody that has access to this Logic app will be able to sign transactions on behalf of this key. So that's one thing to note. But as Supriya mentioned, the key is stored securely and won't be exposed from that point on.
Right. So this page now asks you for the contract ABI, which is the smart contracts API, and the public address of the smart contract, which I can get from my remix page. So this is where the addresses can be got. And to get the ABI, I move to the compile page, and here's the ABI.
So for those of you who are not familiar with Remix, it is an in-browser Solidity compiler, and it allows you to interact with the blockchain. So you can deploy contracts and you can interact with those contracts.
And now that I've entered the ABI and the smart contract address, you will see that this drop-down will be populated with the name of the event that this smart contract exposes. And I can select that event to trigger based off of that.
That's really cool. So it's automatically populated based on the ABI that you passed in.
Right. And I want to trigger it every minute, so I'm increasing the frequency.
So that means that every minute it's going to it's going to look at that Ethereum contract and see if there are any new events that have been fired since the last time it ran? Okay.
Yes. And if the event is triggered, then I can take some actions on, I'm going to use the blockchain connector again and read some state off of that. So for example, on my contract, I could read the message as well as get a count of the number of messages it has received.
Because those are the two public properties.
Public properties.
Got it.
And there are other things I could potentially do. I could deploy another smart contract, execute another smart contract function, which incurs gas cost for which I would need the private key, or just query another function without incurring gas cost. But for this demo, I'm going to be using the get smart contract state. And again, I need to enter the ABI, for which I'll go to remix. The reason you need to enter the ABI another time is because theoretically you could be working with another smart contract here, something different from the previous one. And I need the smart contract address.
So I'm already thinking of all types of scenarios you could build where you're taking content from one blockchain, writing it to another blockchain, and based on different contracts data.
Right. And if you wanted to write to another blockchain, you would just have to change the connection here. Right now, it's using the same network that I had previously set up for the previous step. But if you, like you said, if you wanted to write to another network, you could just change the connection.
That's really cool.
And so now I have read the state of the smart contract here. And the next step is getting fancier. I'm going to write to Blob store. And here again, I need to create the connection to Blob store and select one of them. Okay.
So one thing to note is that these connection objects can be reused across multiple instances. So it's something that you set up once, and you can just it's set it up in the background and for each of the new connectors.
So I want to create a new blob every time this smart contract fires this event, and use it to perhaps count the number of messages received or create a new unique blob based on the number of messages.
Okay.
So like you can see on the right, the dynamic content has been pre-populated for you. This is based off of previous Logic App steps.
I see. So the content on the right is essentially output from the previous steps in this flow.
Right. So I'd like a count. So that's going to be the as part of the blob name, and probably in the content, I'll put in the message that was sent to the blockchain contract.
So this is neat because as a Logic App developer, I didn't have to worry about naming these variables. It automatically picked it up from the
previous
contract.
Step. Right, from the contract and the previous execution of the previous step. Right.
That's great.
And I'm happy with my Logic App workflow, and I'm going to save it. Okay. And now that it's saved, I'm going to start running it. And in order to see it work, I have to obviously trigger an event on the smart contract, which is what I'm going to do with Remix. I'm going to post a message on the smart contract. I'm going to call it Hello Blockchain. And this is the message that is sent to the contract, and which I hope to see finally in Blob store. Okay. The transactions should be sent. Was it sent?
If you open up, if you close that and then open up MetaMask, you'll be able to see if the transaction went through. And you'll, from here, you'll say cancel. a reject. And it looks like the transaction was mined.
Mined. That's great. Thank you, Cody. Yes. And now I should be able to see that the Logic App workflow ran. It was triggered.
Great. So those green checkboxes mean that it succeeded? Okay.
Yes. And now I should be able to see the blob. This is where I expect to see the new blob store created, blob container created. Blockchain message 7 was created. You can see that the count got appended to the
awesome
name. That was the 7th message that contract had received. And if you look at the contents of the blob, here's my message. Hello,
success.
Blockchain.
Nice.
Thank
awesome.
you.
So what we saw today was the ability to set up an Ethereum Logic App Connector. You could take data that's triggered from the blockchain. You can have that trigger launch a cascade of different actions. And the action that we decided to take was reading contract data and then writing it to a blob store.
Right.
That's awesome.
And there are many other things you could do. Integrate with Outlook and send an email, or send an SMS message. And the triggers could also be, when you receive a certain email message, you could put the contents of that into the blockchain. It doesn't have to be just a trigger on the blockchain. It could be triggers on any other Logic App connectors that then feeds into actions on the blockchain.
That's awesome. So I can imagine all the different types of scenarios where you take content and just checkpoint it onto the chain as relying upon that chain's immutability.
Correct.
As part of the feature.
Yes.
That's awesome. So let's take a look now at all the different Ethereum connectors that we've built. So today we saw the trigger, which was based on the Solidity event, and then we saw the ability to read the full contract state. So Supriya, can you talk a little bit about the other connectors that we've built?
Okay, so these are all actions that you can take on the Ethereum blockchain connector. The first one is deploy contract. You can, if you have an account and its private key, you could deploy a contract and the ABI of the Solidity ABI of the contract, you could deploy it. You could also do a state update, which means you can change the any state on the contract by sending a signed transaction, for which you need a private key again. The query state is the inability to read all the public properties that the contract exposes. For this, you don't need gas. You don't need to need the private key to be sent.
Got it.
And read the full contract is reading all the properties of the smart contract. The previous one, the query state, is where you can call a specific function, whereas the read full contract is the ability to read all the exposed public properties.
Got it. Very cool. So the Ethereum Logic Apps is the first set of blockchain logic apps that this team has launched. But in the future, we're also planning on launching logic apps that are dedicated to different types of blockchain ledgers. So I think if you are interested as a viewer in any of these different other ledgers and want to see logic apps for them, let us know in the comments and we can make sure that we prioritize accordingly.
Right, and if you want to try out the blockchain connector, you can also use, I think Azure provides you some free subscriptions that you can try it out.
That would be a good place to get started. And we also have our Ethereum Logic Apps docs that you can check out that we've published at aka.ms/ETH Logic App. So that's ETH Logic App. And I think that's it for today. You can follow us on Twitter at MSFT Blockchain, And you can always subscribe to this on Yammer, Channel 9, or on YouTube.